Good afternoon, everyone. I hope you are having a wonderful day. Thank you for joining us today. These that are in the live session, I'm glad you made it. Now, one thing I just want to point out, and I'm assuming it's really not the time to say this, but a Thursday tutorial is probably going to be one of your more interesting tutorials. For the simple fact is, it's where we will teach you concepts. Maybe not something that's going to be examined, but interesting concepts. It's also where we use most of the time to discuss practicals. And if you have any issues with the practicals, specifically a concept in the practical or something in the practical itself that you might be struggling with, this would be the best place to, get a live result on that question. But without further ado, let's get started with today. So today we're going to give you a gentle introduction into data structures. Now, I'm going to present mainly two data structures to you today. And these data structures can get expanded or will be expanded in your third year. And I think in computer science in your second year as well. And they become very useful. So if this small section confuses you, don't worry too much about it. Like I said, I'm just introducing these concepts to you. You will formally learn of them in your third year, and I think in your second year. I can't remember if you do it in ComSci too. It's been so many years. So the purpose and the outcomes of this small data intro, I guess, is to tell you what is a data structure, essentially, to introduce you to a stack, a queue, and a tree. So those are the three main data structures we'll be discussing today. So, a data structure. So these are structures that are organized in such a way that allow data to be processed, such as storing and accessing in an efficient manner. So it gives you the information in one place. It means it makes it easier to access the information. So take this disk as an example. The documents are in a certain organized in some manner. But you have to admit it's difficult to access a particular file that you are looking for. It is also a sign of genius, don't judge me. Right, so this is actually a picture of one of your lecturer's offices. Well, not specifically one of their offices, but their office looks fairly similar to this on a regular basis, and so does mine. Now, the problem here is there is some form of structure here. You can't actually see it. It looks very messy. There is some form of structure here. But accessing a particular file that you might need it's not very easy. And you need an easy way to find the information that you want, even if it's just an approach that you can use to find that information. So these structures that are organized in such a way that allow data to be processed, such as storing and accessing in an efficient manner. And the idea here is so that you can access them in an efficient manner as well. Storing is not always done efficiently, as you will learn next year, but accessing is important. You don't want to wait forever to access information. If you want the information, you want it now within a reasonable time. And I say reasonable time because you can't always go with the most efficient option. It's not always the most appropriate option to use. The documents here are arranged a lot more orderly with better structure. This means that it would be easier to store things away and retrieve the ones you want easier. So efficiency. Now, from the picture, you can see the things are labeled. So you will be able to find things very quickly, but you'll also be able to store things very quickly in a way that you want them. Now, the same thing with the desk. Storing information here is very easy. You just kind of like throw it on top. But accessing the information, it's not that easy. It's the efficiency is not with accessing, but maybe with storing there. So a data structure that you're already used to is the record structure. So the record structure you worked with in 1A are some of the examples of storing information together to make it easier to store them and to access them. So with your record structure, you combine the information into a category. In this case, we've got a student, and the information about the student, the number, student number, the surname, and whether the student have graduated or has yet to graduate is stored. And you can very easily find that information. You can go to that specific student and you can retrieve this information very easily. So everybody okay with that? A general data structure that you're used to, which is actually a custom data structure that you create, is the Humble record structure. And I say humble because all it does, it just stores information. There's no methods inside the record structure. It's just a structure for simple, easy to find information and simple objects, essentially. Everybody okay up until there? Any questions regarding data structures so far? Okay. Now, the first formal data structure I want to introduce you to is a stack. Now, before I show you, well, you can kind of see the outlines on the left-hand side, but if you think about a stack, if I tell you to stack something, what does that tell you? If I tell you to go and stack those books, what does that mean? Go and stack those plates. What does that mean? A pile, yes. And what do you know about a pile? One on top of each other's. Yes. Organize, debatable, I guess. But pile on top of each other. That's important. If you think about a stack, is you put one thing on top of the other. Now, this pile works like you would think. If you want to remove something, where do you remove it from? Let's say you've got a stack of plates. Which plate will you take off? Which plate is the first one to be removed? The one at the top, yes. Would you take a plate at the bottom? If you live dangerously, yes. Okay, so normally you would not. So when you work with a stack, is normally you would take off a plate from the top. Let's say you want a plate from the middle. What would you do before taking that plate out? You would take off the top half. So you take off all the plates up to the plate that you want, and then you can take that plate out. Now, if we look at a stack works the exact same way as we just described. A stack is an example of a data structure. It follows a concept called last in, first out principle. So much like a stack of books or a stack of plates, the last item to be put into the stack is the first item to come off of the stack. So to insert an element to the stack, we would push it onto the stack. So the keywords that we would normally use is we would push an item onto the stack, or in the example, an element onto the stack. When we remove something, we pop something off of the stack, removing the top item of the stack, and then the very top element of the stack is also referred to as the top. So very easy, straightforward, and an example here of a stack that I have is an ice cream cone. Ideally, you would not start at the bottom of the ice cream cone to eat that ice cream first, because then the top part might fall off. But as one of you said, you can live life on the dangerous side. But it is ideal that we remove one from the top and not from the bottom. But there are procedures in place if you need to remove something from the middle of the bottom. Do we give stack defined sizes or dynamic only? Now, it depends on your implementation of the stack. You can give it a defined size, or you can give it a dynamic size. It just depends on your implementation. In third year, the first concept you will most likely learn is the dynamic range. Because when you work with a stack, you start off with one item. So you have an array of 100 spaces, and you keep on popping items onto the array, but only 100 spaces can go into that space. So if you work with a size limitation, you can do it like that. Or you can start off with an array of only one item, and then as you add items to the array, you would resize the array and then add the next item. Right. Then the next concept or data structure that I want to discuss, and I'm going to stick to the main data structure here. I don't want to confuse any of you with the other data structures out there. But if you want to have a debate like that, we can do that in Discord. I'm more than happy to give you all the information about the other data structures there. But for the tutorial, let's stick to the three main ones. Right. So the next one is a queue. And once again, if you think about a queue, what do you think about? You think about a queue standing at a shopping mall or at the bank or at a fast food joint. Where do you start this queue? First in line, first out of the line. That should in reality be the best, or should be the only consideration, but I guess it's not always. At the front, destination. At the back, first in, first out. Yes, there's the term I'm looking for. So with a queue, the first into the queue is also the first out of the queue, as was mentioned. And yeah, that is the term. That we actually use that as the abbreviation. Same for last in, last out. LILO. So if you think about a queue is another example of a data structure. It follows a first in, first out principle, much as with a real queue, the queue in real life. The first item you put in will be the first item that comes out of the queue. Now, the terms we use here is when we insert an item into the queue, we enqueue the item. When we remove an item from the queue, it's a dequeue. And then you also have a name for the first and the last element in the queue, which is front and back. So pretty much the same way that you would describe a general or a regular queue. Very easy, very straightforward, no issues. Now, the next one, a tree. And this is where this is one of my favorite data structures, is a tree, because you can do so much with a tree. A tree and a graph is two of my favorite data structures, but you'll learn about graphs much later. So when you think about a tree, where does a tree start? Not the first node, but the root. It starts at the root. And then what does it do from there? It grows up, it branches out, it goes up. So it grows. As a tree grows, as you have a branch of a tree, what grows on top of these branches? What's at the very tip of the branch normally? Leaves. Yes, that is correct. So at the end of these branches, you have leaves. So when we look at this, you'll see that a tree, so the last example of the data structure that I'll be using for today is the tree. So you can see a tree starts with a root. That's the first element that there is. And if there is only one element, that one element is the root. So a tree starts off with the root. So from that, we get the nodes. Now, each one of these elements can be referred to as a node. So be very careful for that. Each element in a tree is a node. The node can either be a root node, which means it's the very first item, or the center item, I guess. Or it can be a leaf, if you look at the two extremes. And the leaf is the very edge of the tree. It's the last, is this mouse? It's the last items in this tree. Now, there is different terminologies. I didn't add that here. So there is different terminologies for these nodes. And that's one thing I also want to discuss briefly. So A different term for a root node that has nodes connected to that can also be referred to as a parent. But now, keep in mind, it's not just a root node. A parent is the node that a leaf branches from. I'm going to say leaf for now because I haven't introduced the second term yet. So the parent node is a node that's on top of your node. Let's just call it on top of your node for now. So your root is the parent of these three nodes that you can see, because it's directly on top or directly above these three nodes. These three nodes, in conjunction to the root or in relation to the root, will be referred to as the children nodes of the root. So the nodes directly beneath a node is referred to as the children. Now, if the child node or the children node is the very last node in the tree, it's also referred to as a leaf. All right, everybody still with me there? Okay, now I'm not going to expand too much on trees, even though it's very tempting to do that. But there are many differences or different types of trees. You get binary trees, you get red black trees, you've got 2-4 trees, you've got just general trees in general. You've got a heap, which is a tree structure. That's why I didn't want to discuss it earlier when it was asked. But a heap is essentially a tree structure, but you'll learn the full concept of that in your third year. Well, essentially, a red black tree is also a 2-4 tree. It's just different implementations of it. But like I said, you'll learn about that in your third year, so I'm not going to expand too much on that. You also have priority trees, and there's many different implementations. And then after that, you'll also discover maps, a data structure called a map. You'll discover graphs, which is one of my favorites. Graphs and trees are my favorites. It's what games also use, if you're ever interested. But yeah, that is the three main data structures I wanted to introduce you today, just to show you that there are more concepts out there. But the one thing you need to know, that each one of these nodes, you talk about a node here, is a representation of information. Same with a stack. Let's just go to this line. Same with a stack. Each one of these elements is information. Each one of these can be essentially a class of information. So it can have its own methods, it can have its own instance variables. There's a lot of information you can store inside of these. These are just data structures you would use to maybe make them more accessible or make the accessing or storing of them easier. All right. But I'm not going to go into too much detail there because, there's an entire course dedicated to these advanced data structures in your third year. So you're going to have that fun. So just be patient about that one. Now, the next thing I want to discuss today, I guess I can just do it below here. Let me maybe start a new one. Something I want to discuss here is the practical for tomorrow. I think that would be enough. 3 clients. Let's say 3 weeks. Okay. So for tomorrow's practical, you were asked to do an application. Let's maybe just go and pull up that practical. And we've had a few questions regarding the displaying of information, specifically the displaying of the weight gained. So I just want to do a run through, let's call it a test data implementation. I'm opening the wrong one here. Test data implementation of the algorithm that you are technically supposed to be using. these 4 weeks. If you're referring to the data structures, you can't use the data structures I just showed you because it's implementation specific. It's a data structure you use to help you solve a problem, and the problems we will give you for the practicals are not that advanced. All right, now going to the question here. So I'm not going to discuss the information that's required. I'm assuming everybody is comfortable with that. I'm just going to discuss the display information that you want. So each week, the client's weight is entered to track the changes. The average weight increase needs to be calculated, and then the total weight gained on the number of weeks, or over the number of weeks, and that's supposed to be over the number of weeks. So let's look at that realistically. Let's go to our sheet. We can say client 1, client 2, stop that, client 3. And then we can say week 1, week 2, week 3, and then we can have our average and we can have our total. So for client 1, let's say client 1 weighs 95 kilograms in week 1, the first week that he's being weighed. In week 2, the client weighs 100 kilograms, and in week 3, the client weighs 105 kilograms. Then for client 2, weighs 80, 82, and 84. And in week 3, the client weighs, let's go 75, 72, 78. Let's actually make this one, yeah, 78. Now, yeah, but you weigh a person. So the mass of the person, I guess. Because if you look at mass, if you really want to talk about that theory, your mass stays the same, your weight changes depending on the gravitational pull of the Earth or the planet you are on. Looking at the average, what is the average weight gained for client 1? What do you guys think? 5, yes. And then for the second client, the average weight gained, what would that be? 2, that is correct. Now, for the last client, what is the average weight gain for the last client? You say 3, 1.5, 1. Okay, so let's leave that one out for now, and we'll come back to this one. Now, let's look at total weight gained. Client 1, what is the total weight gained for client 1? Ten kilograms, yes. And for client 2? 4 kilograms, that is correct. And for client 3? What is the total weight gain for client 3? 3 kilograms. Now, the total weight gained in this case represents the growth, essentially. So since week 1 to week 3, the client has gained 3 kilograms. So what would the average weight gain be for this specific client? We've got 1, 1.5, 1, 3. All right. So I'm assuming the people that are saying 1, 3.3, how can the average weight gain be more than the total weight gained? I think something in your algorithm went wrong. Consider this. Most of you are most likely taking the total weight gained, which in this case is 3, and you are dividing that by 3 because it's 3 weeks. Am I correct in assuming that? The people that said the answer is 1. Yes. All right. Why is that wrong? Why is that the wrong approach? That is correct. The first week, there is no weight gain because that is the first time they're being weighed. So essentially, that is element 0. That is the first element being entered, but there is no gain there. There is nothing to compare the gain to. Where is the first time you can compare them to? The second week. That is correct. Because the second week is the first time you can compare the weight to the first week. So when you look at the average, your average would be the total divided by the number of weeks minus 1. Because you're most likely going to use your n weeks as your divisor. So you just need to subtract 1 from that because the first element in that array is the first weight that you're using for comparison. So it's not something you can use for your average. So essentially, your average year would be 1.5. Now, for the other comment that I saw, total weight gain. So what that person is doing is taking the first week, dividing it by the second week. I mean, taking the first week, dividing. Sorry. What you are doing is you're looking at the weight gain in general. So the total weight gained over the period of time, in terms of this example, or how the question is laid out, is the last time the client is being weighed minus the first time the client is being weighed. The idea here is the clients are saying that they are gaining weight. There's no one's going to use this tool if they're losing weight, because then why are they going to the gym? There's no need for the gym, essentially, in this concept. So you would take the last time the client was weighed, subtract that by the first time the client was weighed, and you've got your total weight gained during that time frame, or mass if you want to be theoretically correct. Yes, Khan. So it would be total weight gain divided by number of weeks minus 1, depending on how you label your things. If you labeled it as, week 0, essentially you can do that, because then you would have week 0, week 1, because that's after the first week of comparison, and week 2. But like I said, I'm going to leave that up to you. That is an application specific, and it depends on how you view the logic of this application. Some might see it as week 1, week 2, week 3. But if you want to really be correct about it, is week 1 is a result of week 1 and not, the first week of attempting this application. So in this example, it is going to be divided by 2 if you want to take the total weight gain and calculate the average. Now, if you increase it, obviously, in weeks minus 1 is the approach there, but just consider how you gain weight and where you calculate the total amount of weight you've gained over a period of time. It's normally from the last time you've weighed yourself compared to the first time you've weighed yourself. You're not going to look at it in terms of a week-by-week measurement and say, okay, I started off with 70 kilograms, I weigh 80 kilograms now, but my total weight gain is 20 kilograms. There is a different term for that, which maybe I should make next week's practical that term. What do you guys think? No. I thought it was a fun question. All right, then let's look at the last part. So the last part of the display information is, so you need to display the total weight gain and the average weight gain, And then ultimately, your program should also calculate and display the average weight gained for all clients combined. Now, this is where I've seen some interesting, I wouldn't say interesting solutions, but confused questions. What is the average weight gained for our 3 clients? Who can tell me, what is the average weight gain for our 3 clients here? $2.8. So if you take your 4 values and simply just divide them by 3, that seems wrong. Let's just take our 4 values, divide that by 3, and we get our calculation. Is that correct? Is that our average weight gained? Yes, it is. Now keep in mind, I'm not asking for the average of the average weight gained. A lot of the students that have been emailing me are seeing this incorrectly. They're seeing the average of the average weight gain. I'm asking for the average weight gained for all clients combined. Which, I guess, if we look at it in terminology, if we look at the if you look at the concepts that are used in your practical, that I might have worded it slightly ambiguous in a certain sense. It can't be average of averages. Well, based on the practical, it can't be. You will be marked incorrectly. Or not marked incorrectly, but you will be marked slightly down on that. All right. Okay. So for the practical, that is, I don't know why. I think students are not doing their test data or doing their algorithm implementation first. Because if you really break it down, if you really just do a test data sample, put it in a grid, go and calculate the values for yourself, you'll see that it makes sense instead of just trying to logically think about the program before you even before doing your design. Then you'll easily see what to do most of the times. Let me just add most of the times. There are some of the times where it's even after the design it still becomes a bit messy. Right, everybody okay there? Any other questions regarding Practical 3? I believe the sound is on. You can talk.
Sir, can you please make an example with weeks?
With weeks?
4 weeks. Instead
4
of
weeks.
3 weeks.
Okay.
Yes, sir.
So in this case, let's just go and remove that. Let's get my design here. Oh, come on, stop that. So let's say 107, we can go 90, and we can go 80. So if you look at the total weight gain, you'll see that the total weight gain here is now 12 kilograms. If you look at the second one, it will be 10 kilograms, and the last one would be 5 kilograms. And to calculate our average, you just simply look at the elements. So you've got comparison 1. So week after week 1, after week 2, after week 3, and divide our total by the number of comparison weeks, which would be in weeks 1, giving you 4. And same for total on the second one. You take 10 and divide that by 3, which would give us 3.3. Repeating. And then the last one, which would give us 5 divided by 3, which would be, let's see, 1.7. 5 divided by 3 won't be 0.66. I think it will be 1.67. Probably 1.67 repeating. Let's see. My mind is not here today. 1.67. Okay, so it's 1.67. And if you round it up, it will probably just be 1.7, depending on how you're going to display it. Or a double, 1.67. Right. And then obviously your total weight gain is just the sum of your total weights. And then the average is divided by your number of weeks. No, I mean, sorry, your number of clients, not your number of weeks. So your average weight gain would be the total weight gain, the sum of the total weight gain of each client, divided by the number of clients you have. Yeah, 1.6 will probably be accepted. Technically 1.7 if you round it up to 1 decimal point, and 1.67 for 2 decimal points. But we're not going to mark it that strictly, though. Evan, I think you're just missing the one in front of your 6.6. Right. So don't think in terms of a fixed number of weeks. Always think when you do these problems in terms of the nth value, because most of these are dynamic ranges. And if I say dynamic ranges, when you look at it algorithmically, you don't know the number of elements until you've asked the client for the number of elements. So maybe set up two test data samples for yourself, one with a simple data set, so 2 each, and then one of a slightly more expanded data set, like 3, 4 each. Now, when you're doing test data, don't make your test data too much. I mean, don't go and add like 5 clients over 6 or 7 weeks, because keep in mind, you need to go and input that information every single time you enter this. So it becomes more difficult. And one thing you can do to test something, to test whether something is working correctly very quickly, is set up default values for yourself. So every time you have your text box of your input box, have a default value there, so that you can just press enter to test it out with one value. Because if you have one value for the n number of weeks, then the total and the average will be that value, and the total will be 4 times that value. So it's a very easy way to see if the algorithm works at a simple level, and then you can go and put in varying levels. Yes, Levin, you can talk.
Hi, sir. So for our practicals, we have our classes, and in my class I've got a private variable that I've declared, and we need to expose that private variable. So I'm wondering, do I rather make the variable public, or should I expose it via a function? Because I exposed it in a function in my prac, but what should I do going forward?
Okay, so keep in mind that when you work with a class, you've got the instance variables. The instance variables always have to be a private or protected in this case. From there, you will have your property method, which will allow you to retrieve that information. So you would use a property method to retrieve that information. And if you're doing a calculation inside your class, then you would return it with a function. So it just depends on how you approach it, but you never work with the instance variables directly outside of your class. Inside your class, depending on whether you have validation or not, you would work either with the property value, the property method, or with the instance variable directly if there's no validation inside the class itself. But if you're referring to something accessing that information outside the class, you will either use a private.
Just referring to, I wrote a function that simply just returns the private instance variable, so it just returns underscore name, or yeah, that's exactly.
No, but then you should be using the property method.
Okay.
Yeah. So you just use the property method, set up the setter and the getter, and then you just return the get with that instance or that variable. Ultimately, it functions like a function, which just returns that value. But for VB,
Is there a
it
point
has
to the
that.
property that has no setter? Because I don't want them to be able to. It's a private set. So would it make more sense to use a function over something with a get and a set?
No, remember, a property method is how you describe it. You can have read-only and write-only property methods. So if you don't want to set it or don't want to allow them to change that value, then you just have a read-only property method. So you have a read-only property, and there won't be a set. There will only be a get inside.
Okay, so it makes more sense to use a property method with a write-only or read-only attribute than to make a function that just returns something.
No, that property method returns the value.
Yeah. So if you make it like a read-only, you can just make it return the value without having a setter, but that's just the same as a function.
It functions the same as a function, but you use a function for your formulas. Let me code it out, and then maybe that will make more sense. Let's open up VB. Let's see. We can use this example. So I'm just using the puppy example that we used. So what you're referring to is
That public property name is exactly what I'm referring to. So instead of having public property name, I would just have public function return name or get name that would simply just return underscore name. Exactly what's done there.
Okay, but all you need to do then is just, instead of having a set, you just remove the set and have a read-only property.
Sure.
So in VB, look, if you're working with Java or C++, then you would use a function and just return that value inside the function. That is correct. But within VB, we're using the property methods. VB and C# uses the property methods, but essentially it is just a function returning that value.
Sure. So it's exposing a private member through a property method instead of a function.
Yes.
Okay. Thank you. That's all I wanted to ask.
All right. Okay, it seems I missed a question here. What do we need to make the class with the methods, or can we do calculations in the form? Now, if you look at the client itself, so you would have your clients and the weight for the clients, as we have the weight for the puppies over here. And then what you can do, you can have either the total calculated in your main form on your buttons, or if you want to, you can have a total weight gain over the time that's being tracked in here, and then return that value as well. But like Mr. Cottrell said, it depends on what type of calculation you want to achieve, and it also depends on your characteristics of the object. Keep in mind that when you create a class, this class has certain characteristics. You give it instance variables, and with this class, there will be certain functions that will go with the class. Certain things that you would like to know, certain things that you would like to find out, that you will have additional functions inside this class. For instance, if we look at what you're currently doing with strings, let's not confuse anyone. If you look at what you're currently doing with strings, you don't actually use string to its full potential. So if you set up a string, let's just set up a test string. You have certain functions that is available to you in this string. So let's give the string just a value. Now, the main thing you can see here is that you're creating an object of string. String is essentially declared as a class somewhere, and you have certain properties that you can use. Now, in this instance, because of how this is set up, we can just simply either declare a value, which mimics our constructor, there are certain functions that you can use with a string as well. So these are functions that are coded within that string class that you can use. Some of these are functions, some of these will be subroutines, and some of these will just be the properties itself, if you want the property itself. So it depends on how you code out or what you want to do with that specific class, what functions will be available inside that class. So there are certain things with string that you would do outside the class, like when you concatenate strings or combine strings together. You would normally do that outside the string and represent that as a new string instead of doing that inside the class string and then just returning that value. I think I'm just explaining it a bit more difficult, but essentially, like Mr. Cottrell said, it depends on the calculations you want to do and what that characteristics is, or what the characteristics is of that specific class. All right. Any other questions? I would refrain from using too many advanced features that are not necessary. But essentially, you want to display information like that. Why do you want to do that? You're overcomplicating the solution. Look, you can use concepts that are taught to you, but try and refrain from using too many advanced concepts. The idea here is not to see how many advanced concepts you can use. The idea here is to find the solution as simple as possible. In your second year and in your third year, we give you more freedom to code with the more advanced class options or features that there are. But for now, we just want to stick to the basics. You can use the concepts as long as it doesn't interfere with the mark sheet. The moment you use something that is indicated or needed in the mark sheet, you will be marked down on that, unfortunately. But just keep in mind, try and keep things as simple as possible for now. In your second year and your third year, you'll have all of the freedom to explore more advanced options. The term legal is a bit iffy, but okay, let's go and look at this. I don't want to confuse the other students. I'll give you a response on Discord. I don't want to put this in the stream and confuse other students. Let me just maybe add a channel to the Discord where you can ask things like that. I'll give you an answer in Discord. Like I said, I don't want to confuse too many people online. I'll also refer you to the official or proper use of the functions. All right. Any other questions regarding the practical for tomorrow? Anything regarding the data structures that we might just discussed? And everybody is quiet. Oh, you guys still there? I think it was last week Thursday. Mr. Cottrell will correct me on that. I think it was last week Thursday that has the UML tutorial. Calculation methods are done inside the class. Like I said, it depends on how you approach your problem. For this week's practical, if you took the if you simply just entered the weights of the clients into a class that you potentially might call clients or person, and then calculated in the main form, that would be accepted as well. but the array of weights that will have to be inside the client. But doing that calculation, you can do that in the main form, or you can do that in the class. Depends on your interpretation of the client from the gym's view. Class characteristics is something that we'll only fully explore really next year, and later on in the semester. But it's about the characteristics that you want for each person or each class, functions and the features that you want to have for that specific person. Now, if you look in terms of a client, and you want the client to be able to calculate their total weight gain over a period, then that is a function that you would put inside the class. But if it's not a gym solution, you actually keep track of weight, then it's something you'll probably just calculate outside of the class, depending on your solution. It's about the logical approach of your consideration of the class characteristics. It is available on Eve. The link is posted there, and you will also see it on Blackboard. It is under recordings, and you should find it under Thursday Tut. It should be on Eve. On Blackboard. So if we go Blackboard, you'll have recordings, and it will be a Thursday recording, and that would have been last week's recording, so that would have been 30th of July. There. It would be that recording. So you can just simply go and download that, and the link is on Eve as well. I'll maybe just, to make things easier for you, no, not that one, that one. Just get the link and post that in the channel. Any other questions? Use class calculations and display. That is the calculations that you might need in the class. In this case, it will more be about how you use the display. Can we put the code for our class in the design algorithm? And how would we write the property methods in pseudocode? Now, the property methods themselves, so when you design a class, when you do the UML for a class, let's take the puppy method and let's do a class diagram for that. So in this case, we have our puppy. Actually, we can just do, no, let me not give you the answers. Well, I might as well do clients. Let's just do puppy. So in this case, we have our puppy as our name. You'll have your instance variables that you'll create. So you need a space for your instance variables. You have a space for your constructors. So you'll have your constructors, but essentially you can either list your property methods with your constructors as well, or you can just keep them as the instance variables. Ideally, you'll have your constructors, you'll have your functions and your subroutines listed at the bottom, your instance variables in the middle, and your name of your class at the top, because each one of your instance variables will have a requirement in terms of private, public, or protected. And then at the side, you can label them how you want. Do you want them read only? Do you want them write only? And that would be the property method implementation. We can maybe set out, I think we did release a guide for the standards that we expect you to use. Just look, Mr. Cottrell discussed it in his lecture this morning, yesterday. Let's see. Lectures. No, it was yesterday's lecture, sorry. So there he has your examples. So you can have your class name, you've got your instance variables, making sure to identify what they are in the front. You've got your constructors under your category, you've got your properties here as well, and then your methods at the bottom, so your functions. So that's the standard we expect you to use. So you list the properties over there. To be quite honest, I'm personally not too concerned about that because everything is expected to be an instance variable, but because it's been presented like this, where you have your categories, constructor, property, and methods. You'll have your constructors there, you'll have your properties there, and your methods there. It's expected that it should be there every single time. We will be expanding on the methods over here, so don't be too concerned about functions inside the class right now. We will be expanding on that, and it will become a bit more clear over time. So let's see if I missed a question here. Yes. I didn't include any of my class functions, procedures, my algorithms going forward. Should we look? It depends on the characteristics of the class. So going forward, you'll have more information about the characteristics we expect you to have in each class. But for the time being, unless you're told explicitly that a certain function needs to be inside a class, it is up to you. It is the logical approach to your characteristics of a class that should be there. If it's not a logical approach to have a certain function inside a class, then we don't. It's down to how you interpret the class characteristics. So we're going to go on expanding on this, and you'll see over time that based on the things we expect you to do, is we expect you to start including more and more methods inside your classes and do less and less inside your main form, because it will become more logical to have these functions inside the classes. So for now, it's fine not to have it inside the class, but as we go forward, you'll see that we start describing the classes in more detail in terms of what functions or features should be characterized in each class. Yes, you have your hand raised.
Hi, sir. I was just going to ask with regards to using classes and doing calculations in functions in classes. Is it a good practice to, instead of using your instance variable, to just call its property method again, just so that you can have validation every time you use it, or is it unnecessary at that point?
Okay, so that's a good question. So when you work with a value, let's use the properties that we have here. If you have a function that's going to use one of your variables, if there is a validation set in your property, like you validate the value inside your property, then you use the property. If there is no validation for the set of that specific attribute, then you can use the attribute or the instance variable directly.
Awesome. Thanks, sir.
All right. So it's only when we have validation in the properties that we want to use the properties over the instance variable inside our class. But if you're using it outside your class, you always use the property. You never use the instance variable directly. Right. There's still a bit of time left. I think there's still about 30 minutes or so left. So if you have any questions, please, you can ask them. I've presented what I wanted to present today. So if you have any questions regarding the practical or any concept in the coding that you might be struggling with, please do ask them so that we can help you with that. Maybe explain it to you a bit better. You guys are very silent now. Assuming you're sticking around to find out some of the secrets. I'm pretty sure you still have more questions for us. Do we need to comment on class also? You always need to comment your code, whether it's a class, a function, a feature, your main form. Every single part of your code needs to be commented. Commenting is good. It's a good coding practice. Especially when you start this, creating more intricate functions inside your class. Well, with the structures, will we need to make our own? We use the built-in structures. Well, you're building your own. I mean, you're creating your own class. What are you specifically referring to here? Because if you think about it, in the example of Tuesday tutorial, where we use the puppy shelter or the shelter, that puppy is a class that we created. It's a structure that we created, and then we used it. So we have our object of that specific structure. Because each class that you create is essentially a custom structure that you create. Well, it's a class, but I mean the structure inside the class is custom. Or are you referring to something else? Oh, okay. Now, I'm not going to expand too much on that because, like I said, for the data structures that I showed you earlier, they taught in absolute detail in your third year. But essentially, you'll have a number of classes that will define how you use the structure. A tree structure, it uses different ways to do them. I don't want to go into too much detail because there's different ways in which you can create a tree. So essentially, each node in the tree will be a class because that node represents information. So it's how you link them together that becomes your tree structure and how you use that. So it's multiple classes that essentially will make a tree. In the implementation I have in my mind at the moment, but there are various ways in which you can create a tree, but essentially each node will be a class, and then how you traverse them as well can be represented differently. No, I'm not going to give you code samples for a tree. It's not within the scope of this semester. And like I said, you're going to have a lot of fun with trees in your third year. I don't think you do it in your second year. But in your third year, you're going to be exploring these data structures, so you're going to be using and implementing each one of them. So I don't want to waste too much time on that. You've got your hand up?
So with a tree structure, is it possible for two roots to link back to the same node? Two different roots.
Okay, but a root is there can only be one root.
Or you can't have like two, then it links back to the same node. Possible.
Are you referring to a leaf node, potentially? For instance, you've got the two leaf nodes, and those two leaf nodes link back to one parent node.
Not entirely. I meant like, is it possible to create two tree structures?
Independent or together? Because if you combine two tree structures, you're just creating another tree.
Oh, okay. I meant like, working together?
Well, if you're combining two trees, you're merging them together. So you're just ultimately creating a bigger tree.
A bigger tree. Oh, thank you, sir.
Okay. So the data structures that I showed you today will only be in theory for Informatics 1B. Won't be in practice. These are simple. These are, well, aside from the queue and the stack, but the tree is a slightly more advanced data structure that you will only start implementing in your second or your third year. I can't remember exactly where it gets implemented, but I think you only start implementing them in your third year. That's why I said I don't want to go into too much detail there, because I don't want guys to get concerned that you're going to have to implement these structures now. It's not going to be expected of you to implement these structures now. That's still further down the line. So if anyone still has questions, please, you can post them. I'll get to them. Well, answer them. All right. Question about the design? What about the design specifically? So will we only be learning 3 data structures this semester? No, we've already discussed a few data structures. Remember, you've already did one. You've already done your custom structure. Wrong slide. Your custom data structure, which is the record. We've done classes now, and we'll be using classes for the rest of the semester. You'll be expanding on classes, but you still have a lot to learn about classes. We've only scratched the surface now. So let's not get too ahead of ourselves. Okay, the UML must be on its own or part in the design itself. It must be part of the design. If you look at I believe we released a template for the design, and then your UML is below algorithms in that template. So you've got input, output, actions and events. You've got your variables, you've got your interface, you've got your algorithms, then you've got your UML, and then your test data. So UML must be part of the design. It's either above or below algorithms. You can decide where you want to put that. Personally, I would put it above algorithms, but because it's a diagram, it's probably needed to have it at the end with your test data. I wonder if I should still be recording this. There's a lot of empty spaces. Interesting way to approach this. I don't really want to stop and start the recording, because then there's multiple instances of questions. Do you still have the test data that you created in this TOT? I think so. I think I actually didn't know it. I think we removed it. We can potentially get it back. Let's see. No, we still have test data. Why do you want to copy and paste my test data now? I guess that's a rhetorical question. I already know the answer to that. Are there any other questions? We still
So, question:
have. Yes, go ahead.
would I be wrong to actually say a class is a form of a record structure which allows methods and which allows methods?
At the bare basics, yes. So with your record structure, the record structure only contained data. You only had I'm just going to refer to as the instance variables, but you only had those variables, and you only insert and access that information. With classes allows you to have that same access, I guess, where you can have instance variables there, but allows you the additional features of having methods there. You've got your properties, so you've got better security in terms of instance variable security. You've got your constructors, so you can have multiple sets of a class and not just the one set essentially. And then the methods that you'll be using for your classes. So you've got a lot of freedom, or you've got more freedom with classes than with record structures. It just depends on how you want to use it. So record structures is limited to the data you use within them. Classes has the data along with methods. And you'll see as we go along that classes still have a lot more features that we haven't discussed yet, because we're still getting to inheritance, we're still getting to polymorphisms. There's a lot of things you can still do with classes that record structures just simply cannot compete with.
Oh, thank you, sir. And can I just ask, is it possible to just set the instance variables which we want the user to see or use as public and leave the others as private?
Are you referring to the instance variables themselves, or the property methods that we use to set or get them?
Instead of like setting and getting certain variables, we could just set them as public and leave those which would like to keep private as private instant variables.
In a class, you never want to access the instance variables directly. It's bad programming practice, and it leaves your class open to certain vulnerabilities. So in the instance that we're going to teach you now, the only thing that you guys are aware of is the fact that your instance variables in a class should be private at this point, and then you will use either property methods or functions to access information inside your classes.
Thank you, sir.
Okay. Remember, I know with VB we're using the property methods to access them, but you'll see with most class implementations that you'll do from here on out, you will always have accessors and, setters and getters, mutators and accessors. And you want to use them to change the values in your class. You never want to work with the variables directly. Otherwise, you might as well just have had an extended array of that information. Look, using classes, you'll only start seeing the benefits of using classes later on in the semester. We're literally just simply scratching the surface right now, and we'll keep on expanding on them. And I know it's something new to get used to, but having public class or having a public instance variable is not a good thing because, like I said, it exposes that variable to the rest of the program, even when certain programs should not have access to it at all. Okay, there's a question. So please go over your calculation average once again. Okay, I'll do that in a second. And the second question is, so does the weight have to be an integer, or would it still be okay for it to be a double since it doesn't specifically or specify in the bracket? If you look in terms of weight, you should actually use a double and not an integer. Because if you weigh yourself, it's generally point something. It's fairly rarely on the dot. So you should be using a double. The integer would be the wrong data type to use. How would you calculate total weight gained? I'm assuming you came to the TUT slightly later, but I'm going to go over the calculations now. What should we format to, as it does not say? Well, you can format it to 2 decimals, but because it does not specify, you can't be marked down if you don't format it. Look at the mark sheets, what are required. And to my knowledge, we didn't say earlier in the semester that if you're working with decimal values from here on out, it must be formatted to 2 decimal values. So you don't have to format it at all. But if you want to, you can. It's nicer on the form when you display it. All right, going over the calculations again, let's maybe just clear out all of this. So looking at test data that I'm going to consider now, we're going to be tracking 3 clients over 4 weeks. And then we're going to calculate the total and the average. I guess the total would actually be the column before the average, but it depends on how you want to label them. Once again, labeling and displaying, I'm not going to dictate to you how much or where specifically, as long as they are there. Now for client 1, week 1, so week 1 is the first time they're being weighed. So that's the first time that you would enter a weight into this table. So for week 1, client 1, we're going to say the client weighs 100 kilograms. Week 2, let's say 105. Week 3, 110, and week 4, 115. So let's do all of them before we continue. For client 2, let's go 80, 81, 82, 83. Really, that client doesn't eat fast food or is very lucky. And then for client 3, we've got, let's say, 70, we've got 68, we've got 72, and then 74. So when we look at the total weight gained, how would you approach it? What is the total amount of weight that the first client gained? $15? $15, okay. Now, how did we get to that answer? How did you get to that answer? $115 minus 100, max minus min. Okay, so the person that said max minus min, what if I did the following? Week 4 minus week 1? Yes. So ideally, you want to take the last time the client was weighed and subtract that, or so you take the last time the client was weighed and subtract the first time the client was weighed from that. And that will give you how much the difference is between them. But essentially, the weight difference is how much they gained. Now, in this instance of the application, we're considering that clients are complaining that they're gaining weight. So there shouldn't be a situation where the last time they are being weighed would be less than the first time they are being weighed, but there is that potential. So min will always be week 1, right? Because we started at week 1. Not always. Like I said, if you look at the very last climb, the least amount he's weighed was 68. And that was week 2. It wasn't week 1. So be very careful for those assumptions. But ultimately, if you look at the total weight gained, you just take the last time the client was weighed and subtract that, or sorry, you subtract the first time the client was weighed from the last time the client was weighed, because then you know how much he has gained over that period of time. So you don't go and look at every single one of these. Okay, he's added 5 kilograms, he's added another 5 kilograms, he's added another 5 kilograms. Just go from the first time the client was weighed, subtracted by the last time the client was weighed, subtracted by the first time the client was weighed, and you'll have your total weight. And then if you do that for the second one as well, so over here we've got 3, and over here we've got 4. So the question here is, but sir, in terms of the question, they're asking how much the client gained. So I looked at it from the least weight at a given point to the highest weight they were at. Yeah, but if you look at the question tells you your program should display the following information. For each client, you will need to display the client's name and the weight entered for each week, as well as the average weight gained and the total weight gained. So the total weight gained, on the number of weeks, or over the number of weeks, is essentially the weight gained from day 1 to the last day they were weighed. If they gain and lose weight in between, that is all fair and nice and dandy, but ultimately you want to know what is the total amount of weight they gained over that period of time, because then you can establish an average. If you take the average week by week, you might find that it might differ slightly. Well, actually, statistically you won't. So you need to take from where they started to where they ended. Because if you take the minimum, let's say you actually use this as an advertisement. If week 3 was their least amount of weight, and week 1 was like less or more, then you're using inconsistent results. You're not looking at it from day 1 to week 1 to week 4. Sir, is it too late to inform you if we need feedback from the assistants about our practicals? No, just email us. If you email us generally before the morning that we send the memos to the assistants, then we can still indicate to them to give us more feedback per student. Otherwise, just afterwards request feedback. You can do that as well. So after your marks are out and you're not sure where you lost marks, you can just always email myself and Mr. Cottrell. You need to email both of us, and then we will most likely respond with where you lost marks or where you need to focus. Okay, now getting back to the example here. So you take the last time the person was weighed and subtract it from the first time, subtract the first time the person was weighed from that, and then you have the total amount of weight the person gained during those 4 weeks. Now, if you thought of it in terms of what the minimum weight was to the maximum weight, it's not within the scope of this question. Even though it might have seemed correct, it's not within the scope of this question, because the idea is not to see the total accumulated weight, it's the total weight gained. If you look at the total accumulated weight, that might be something different. We would actually go and see how much weight was gained, even that if that is not the total weight gained. I looked at it mathematically. Well, all of these approaches are mathematically, including the displacement of weight. Okay, fair. So you looked at it in terms of the total accumulated weight. So you looked at literally every pound gained, not considering weight lost in that time as well. Every kilogram gained. I don't know why I said pound. It's not realistically the total change, because if you take it that way, you would take the amount that they've lost as well. Because then you would take the negative weight gain and add that to the positive weight gain, ultimately cancelling out that total change. Can't look at it from one side and not from the other side as well, if you wanted to look at it in terms of total displacement, as you describe it. Right. But it's a simple thing to go and correct. It will take you 2 minutes to go and fix it. Right. Then looking at the average weight gain over the period of time. So this is something that you can look at it week by week if you want to make it really difficult for yourself. Or simply look at the total weight gained and subtract that by the number of weeks that they were monitored. Now, I'm assuming for the person that came late, that didn't see our first introduction into this. When was the first time this client was weighed? Week 1. Now, what is the total weight gained for week 1? Is there an answer for that? Why and why not? Why not? Merlin? It is the first week. That is correct. It's the first time the client is being weighed. So if I say total weight divided by the number of weeks, 15 divided by 4, would that be correct? No, because the first week doesn't give us a comparison. And I said this earlier, but we use the amount of heritable weeks that we have. So we've got week 1 compared to week 2, week 2 compared to week 3, and week 3 compared to week 4. So we've got ultimately 3 weeks of change that we can monitor. So week 1 establishes our baseline. And then after that, we have after week 1, after week 2, after week 3. So you would have your total weight divided by your number of weeks. So number of weeks minus 1 to get the correct results. So your result will be 5. Then for your second one, you do the same thing, and in this case we have 1. And then you'll do the same for the last one, which would be 1.3 repetition. No. Yes. So 1.33 or 1.34. So Milan, are you with me on that one? You asked me to just do the calculations again. Okay. So you're comfortable with those calculations now? All right. I think in future, if I do more kind of like tricky questions, I'll probably add like a small test data table at the bottom so that you can look at them. But I only realized after I gave the question that some of the students won't actually see that until they code it out, and that would cause an issue. So it's just one of those things. I don't think we'll maybe subtract 1 mark for that mistake. I don't think we'll penalize it too much. But it is something that needs to be considered. It's part of the problem-solving landscape that you guys need to get used to, is the fact that even though the solution seems very simple, there might be something small that actually causes a mistake. And in this case, it's literally just off by 1 because of our considerations of how we describe the weeks. Because I could have very easily just changed the sentence to make more sense, which would have allowed the use of n weeks as the divisor instead of just n weeks minus 1. All right. If you guys don't have any more questions, I am going to ask you guys to please either leave the session or ask questions, just simply so that I can see whether I should still keep the recording going or stopping it. Or you guys can stick around, doesn't matter. But if you have any questions, please do ask them. Otherwise, after about 5 minutes of no questions, then I'm just going to stop the recording. So you guys are more than welcome to stick around, ask more questions. It doesn't have to be specifically related to the practical now. You can ask any questions, seeing as we've covered the concepts and the practical. So you guys can go ahead and ask anything applicable to the course, of course. All right, we've got a question here. So dividing by number of weeks minus 1 is the formula to find the average. In this case, yes, depending on how you created your n number of weeks. But yes, if you label it like I labeled it, that you would take the number of weeks minus 1 to get the correct average. Because remember, week 1 doesn't have a comparable value. You don't have a baseline to start off with, so week 1 becomes your baseline or your base value. How did you approach it? Because this is based on implementation, because I know of a student that emailed me that said they actually took a base value. So they recorded a base value, and week 1 was compared to that base value. So week 1 was literally the results after week 1, which is also a correct way of doing it. That's just a different way of doing it. I basically added the number. I basically added the weight and divided by the number of weeks. So you took the average weight of the person over the time frame. So you took, in this case, that would be, what would that be, 420 divided by 4. Is that what you did? But that doesn't give the average weight gained. If I asked you what was the average weight of the person over this time frame, then that would have been correct. But the question is, what is the total weight gained? So gained is the key phrase there, and the average weight increase, or essentially gained, during that period. So you just missed that. We only looking at what was gained and not the total weight of the person week by week. And that's a small mistake. It's misreading one word that causes something like that. Because you probably would have had a result of, that would be 105 there. Were you aware that you misunderstood it from the start? Or did you only realize now? Only now. Okay. I think the practicals going forward will be maybe a bit more clear. I'll try my best and make it a bit more clear. Okay, any other questions? You still have, I think, 10 minutes left. Oh no, actually not. is the end. Okay, so I'm going to stop the recording here. If you guys have any more questions, please, you can post them on Discord. You can email them to us as well. I have no issue with that. And we'll get back to you as soon as possible. I hope you guys have a lovely day. I hope you guys are enjoying this practical for tomorrow. And I'll see you guys again tomorrow during the practical sessions.